Okay guys, welcome. We're starting lesson 8. We're going to solve percent problems. Okay, it continues from what we learned last week. And again, the question to keep in mind is, when is it better to use a fraction, a decimal, or a percent? We have two goals for this lesson. The first one is to use number lines to find the whole, and the second goal is to use the percent proportion. All right, let's go over goal number 1. I want to go over that just a little bit. Goal number 1, basically what you have to do is if you know the part and the percent, you can find the whole or the total. Okay, we've done this before, that's why I put a reminder here. Last week we did something like this. 10 is 25% of what number? Okay, and I set up two bars, and you write what you know. We know we have 10%, sorry, 25%, and as always, we have a percent bar and a number bar. I should have said that earlier, but I'm saying it now. Let me see if I can fix this just a little better. There you go. So we have 25%. And we're always going to have 100%, so that's a given. But here's the deal. 10 is right there, is part of this bigger number, this bigger whole right here. 10 goes with 25. What goes with this 100%? And what we did last week was we set up two equivalent ratios. Let's see if I can zoom in a little bit. Part to whole. 25 is the part, 100 is the whole. 25% to 100%. We know 10 is the part, but we don't know the whole. Now, I can't scale up or down, so I simplified the 25 per 100 into 1/4. Right? Remember, if you can divide by a factor of 25, you have 1 to 4. Now, you should be able to see that you can scale up 1 by a factor of 10. 1 times 10 gives you 10. You do the same thing with the 4. 4 times 10 gives you 40. Kind of go on the side. There you go. So what we just did was, hey, we have the percents, we have the part. We're trying to figure out the whole. We did this last week using bars. Now, what you're going to have to do this week is use a number line. Okay? Kind of went ahead and did this. Let's see if I can fix this a little better. Okay. Now I'll use a number line to find the same thing. Find the total and the whole. Right? You're basically going to draw two lines, a percent line and a number line. Now think about a percent line, you're always going to have 100%. Maybe more, maybe less, but you'll always know. If you have something less than 100, you always know you're going to have the goal is to have all of it. 100% is the whole. Now, let me read the problem again. 10 is 25% of what whole? So 25% to 100%, we have 10, but we don't know is the whole. Okay, now I kind of went already ahead and did the work, but let me explain how I got it. Don't just copy this and say, oh, I get it. No, let's think it through. From 0 to 25, I realized, hey, if I keep adding 25, I'll eventually get to 100. So what just happened here? I divided the line that goes from 0% to 100% into 4 parts. 1, 2, 3, 4. And that works out. 4 parts, 25%. And if I add 25 plus 25 is 50%, plus 25% is 75%, plus 25, 100%. Okay, now we have the number line. Now, if I divided the percent line into 4 parts, I'll have to do the same thing with the number part. So, and same thing. From 0 to 10, you know what? I'm adding 10. I'm adding 10. Adding 10. Adding 10. 10 plus 10 is 20. Plus 10 is 30. Plus 10 is 40. So 10 is 25% of 40. Okay? So that's all, it's basically the same thing. Now if you want, if you can imagine, if I turn this into a bar, just add another line, and I flip it over like this on its side, you've been doing that all along. You really are just you're setting up equivalent ratios. Right? Anyways, let's get started with the guided practice. All right, the first one, or something, not the practice, got it. The first one is letter A. The question asks, 30 is 50% of what number? Okay, same thing. You're going to have to draw two lines. A number line, a percent line. Now, it doesn't matter which one you draw first. It really doesn't matter. Just be consistent. Numbers stay with numbers. Percents stay with percents. You might want to draw the lines a little larger just because you want to be able to divide things evenly, be able to see it. All right, so what do we know? We have, or we want to know, 30 is 50% of what number? Okay, we don't know the total. We're trying to find it. That's what we don't know. We do know we have 30, and we know that's 50%. Okay, 50% is right in the middle. And when we have everything, we have 100%. And with the 50 goes 30. So 30 is 50% of what number? Okay. Well, let's look at what we just did. Percent. We just broke up the percent bar into two parts. We did that here too. Well, from 0 to, again, you'll always have 0, right? Just like you'll always have 0 here. From 0 to 30, we added 30. Okay, then we'll do the same thing here. We'll add another 30. Right? Well, guess what? Now that becomes 60. Okay? Fair enough? So the answer here is 60. It's all about what you know and don't know, okay? Don't overthink this. All right, now we're going to do letter B. Letter B. 60 is 20% of what number? Okay. This time I'm going to draw the percent line. You'll always have 0% when you have nothing. When you have the whole thing, it's 100%, always. When you have everything, it's always going to be 100%. Okay, then we have a number line. I'm going to draw that. Hashtag number. You guys call it hashtag. I just know it's number. Hashtag. I love math. Okay. Again, same thing with percent. You can always have 0, which means you can always have nothing. And you can always have a total, but we don't know what the total is. How do I know? Because here's the problem. 60 is 2% of what number? 20% and 60. We know the 20% and the 60. Now, I could be wrong here, but maybe I'm going to say 20% is right there. And with that 20%, we have the number 60. All right. It's all about thinking here. If you can add and subtract, you'll do fine. Now, I notice from 0 to 20, to get from 0 to 20%, I add 20%. Let's play with this. I'm going to do it again. Add another 20%. Now I have 40%. I'm going to add another 20%. And if I goof up, I can always erase it. I'm going to add another 20%. And if I add another 20%, guess what? I get to 100%. Now, I'm going to stop there. Because all I want is one whole. Okay. Well, guess what? It looks like I broke it up into how many parts? 1, 2, 3, 4, 5. I'll do the same thing here. I'll break it up into 5 parts. Okay? And just look. All you're doing is adding. You're skip counting. From 0 to 60, I added 60. Guess what? You're going to add 60. You're going to add 60. You're going to add 60. And you're going to add 60. So what is that? Well, 60 plus 60 is 120. Plus another 60 is 180. I'm doing this in my head, guys, so just keep in. But you could also do this. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. Which means the last one's going to be 300. And there's your answer. So, 60 is 20% of 300. All right, last one for C. It is a word problem. Let me read it to you. Peyton spent 60% of her money to buy a new television. If the television cost $300, how much money did she have? All right. Same thing. Number line. And like I said, it doesn't matter which one you draw first. The idea is the same. Percent line, number line. double number line. It's two number lines. Ta-da! 0, 0%. When you have everything, you have 100%. This is what we don't know. So this person spent 60 for money. It's a little bit more than half. So she didn't spend all her money. You saw what I did? Guys, I'd like to say I did that on purpose, but I didn't. The mistake I made, like, why did you erase it? 60% should go with the percent line. So make sure you don't make the same mistake. Percents go with percents, numbers go with numbers. So 60%. She didn't spend all her money, she spent this much on a TV. But we want to know how much she had before she spent anything. What was her total? Okay, we know she spent $300 on that TV. And again, I'm just going to draw a little... This may not make any sense to you, but in my day, there was a big old box of a TV, little circular screen in the middle, little antennas, little legs at the bottom. Just label it TV so you know it's a TV. Anyways, so the question is, how much does she have? Okay. Again, this is where you have to think. I have 0 to 60. Okay, so plus 60%. But if I do that here, plus 60%, I'll get 120. I can't do that. So somehow I have to break this 100% into equal parts. No, I can't do 60. But I notice, since it ends in a 0, maybe I can try breaking it up into tens. All right? So let's see. 70, 80, 90, 100, 10, 20, 30, 40, 50. All right, I can break it up into 10 parts. And I'll do the same thing here. The total. 10 parts. No, again. It's a little cramped, but I think you can see what I'm doing. Now, do you have to do this? No. But you should, just so you don't make mistakes. And if you do make a mistake, you'll catch it because you're doing all the work. All right, so same thing. I have to break this up into 10 parts, 300. Well, I shouldn't say this into 10 parts. The whole thing is 10 parts. So from here to here, let's say we have 1, 2, 3, 4, 5, 6. So I have to break up 300 into 6 equal parts. Well, sounds like it's a division problem to me, right? If the total is 300, and I need to break it up into, let me count that again. 1, 2, 3, 4, 5, 6. 6 groups, right? How much is in each group? I'm doing this kind of fast because I'm assuming you guys already know how to divide. All right, that means each group is 50. Plus 50, all right, there's my 50. Plus 50, plus 50. I'm sorry I have to write really small, but this is what I said earlier. Make sure you write your big lines. All right, that's 100, 150, 200, 250. Hey, it works out, 300. And I'll keep doing that. Plus 50. Now, you're asking, why do you write 50%? Because I forgot. Again, I'm going to make mistakes, people. You're going to make mistakes too, and that's okay. 350, 400, 450, 500. Hey, look at that. So the amount of money this person had before they spent anything was 500. Okay, so 300 is 60% of 500. See the connection? Okay, we're now ready for goal number 2, which is to use a percent proportion. Okay, now to use that, you'll have to remember a couple of things. The idea is you have to remember the part to whole, right? We're talking about a regular fraction, part to whole, and the idea of when you write percent, the 100 is always a denominator, right? Per 100. So it's like you're writing two fractions. A number fraction with a part to whole, and nothing but whole numbers, or decimal numbers, or whatever. For right now, we're just going to use whole numbers, makes it easy. And a percent fraction, where the denominator is 100. Okay? All right. All right, so on page 157, we're looking at letter D. Okay, oh, there you go. You can see it, I hope. All right, I'm going to write out the whole problem just so you can see something. 75 is 15% of what number? I was going to use the hashtag. But you know what? Let's not be lazy. Let's use the number. All right. You need to know two things. You have to fill in some information. Are we looking for the part? Are we looking for the whole? Are we looking for percent? What are we looking for? Guys, as you do this, you won't have to do all this work. Since I'm trying to teach you this, I'm showing you everything, okay? All right, so what do we know? We have 75. 75 is the part. How do we know it's a part? Because it says it is, in this case, equals. Think of it that way. 75 is 15% of 100%, right? 75 is 15% of some number, some whole. We don't know what it is. This is what we don't know. Okay? So let me rewrite that a little differently. Here's my part. We don't know the whole. Here's the percent, written as a fraction. Right? 15% is 15 per 100. Again, write down what you know and fill in what you don't know. Is what you have to find. Okay, now we're trying to set up two equivalent fractions or ratios. Now I notice this might look a little weird to you. I know 15 scales up to 75, right? If I multiply it by 5, that means I get 75. But then the question is, okay, well, I'm going to do the same thing here. If I multiply 100 by 5, what will I get? Well, guess what? You get 500. So the whole number that we're talking about is 500. So let me rewrite it so you can see what's going on. 75. There's my 500. 75 is 15% per 100. Now, if you didn't like that, you know what? I know when I started out the problem, when I set it up, I wrote part to whole first, the number fraction, and then the percent fraction here. You can switch the order. You can do the percent fraction first, and then the part and the whole other side. So saying that, what I can do at the end, if I don't like the way it looks, I'm going to write it this way. And it's still the same thing. You're going to say, hey, now I can see that if I do this, because let's be honest, here what we did, we scaled down. We scaled down going this way, right? But some of you don't like that. It freaks you out. It's division. You don't like that. And when I go this way, say multiply by 5, you're like, I don't like that. And switch the order. Now that should look better to you. By the way, another way you can do this. Let me rewrite this just a little differently. 75, we don't know the whole. 15. Since we're setting up two equivalent ratios, you can always simplify this and see what happens. If it ends in a 5 and a 0, that means I can use 5 as a factor. I have 3 over, let's see. Right? That work? Nope. There you go. There you go. Okay. You're like, what's he doing? I'm going to change the order. I was debating whether I should change the order or not based on what I just said. Well, again, how many groups of 3 can you make out of 75? Do the math. Some of you can already do this in your head, but I'm going to do the work anyways. Okay. I can scale up 3 by a factor of 25 to get to 75. That means I'll have to scale up 20 by a factor of 25 to get whatever to get to whatever I need there. All right, I'm going to do the math here. 25 times 20. You can't see it. There you go. 0, 0. 15. I'm going a little fast, but that's okay. Same thing. So guys, so many ways to do this. The point is, keep your thoughts organized, make sure your pencils are sharp, and don't give up. Don't worry about the pencil thing, I was just joking about that. All right, letter B. Sorry, letter E, I don't know why I said B. Because that's what I said earlier, I said A, when it's really Anyways, letter. The other one now. Let me just show you. I just realized I said this is A when it should have been D. There you go. That makes more sense. Same problem, different letter. So that means we go after E because E comes after D. All right. Same thing. 9 is 36% of what number? Again, part to whole and the percent. 9, it's a whole number. It's a number because I don't see a percent symbol. Is 36%. There it is, 36% of what number? We don't know the whole. But we do know 36% is 36 per 100. Okay then. I know if I scale up by a factor of 4, I can go from 9 to 36. So then my question is, what number do I have to scale up by 4 to get to 100? Or 4 times what gives you 100? Right? So let me rewrite this. And again, that's just division. Something times 4 gives you 100. So we're making groups of 4, right? Some of you already know. Try not to skip corners, but... Oh, 25. So the answer for that one is 25. Right? So what does that mean? It means 9 is 36% of the number 25. Yes? Okay, moving on to letter F. 7 is 70% of what number? Okay, again, part to whole, and we have a percent on this side. 7 is 70%. 7 is 70%. 7 is 70% of what number? Now percent, 70%, 70 per 100. So again, you always have that 100 as a denominator. Remember, I reminded that earlier. But we don't know is this. What's the whole number? 7 is just a piece of it. But what piece, or what's the big number that we're talking of? All right. Now, I mentioned this earlier, but I'm just going to do it right now, just so you can see. I'm going to simplify this just so you can see something. 70 and 100 have a common factor of 10. Oh. This should be easy to see, hopefully. Same thing. I want equivalent fractions, equivalent ratios, so 7 times 1 gives you 7. So what number times 1 gives you 10? Well, 10. So again, let's go back to what we're saying. 7 is 70% of 10. Okay? All right, last one. Letter G. I might be going kind of fast. You can always rewind. You can copy these notes over and over again. Again, you're comparing the number and the percent. The thing about percent is we always know the denominator is going to be 100%. Okay, so here we go. 7 is 35%. Now, you might say, well, what happens if I write the 7 here? Well, it's not going to work, because guess what? This 7 here, you're saying the 7 is the whole. It's saying you have, I don't know, 7 books, right? And that would be 100%, right? But that's not what the problem says. The problem says 7 is 35%. Okay, so let me just see if we can do this. You know, I was going to use the bar, but let's use number lines so you can see what's going on. Again, percent. All right. It says 7 is 35%. 35% is somewhere here. And 7 is right there. 7 is 35%. That's what the problem says. 7 is 35%. If you write 7 at the bottom, you're saying I don't realize another mistake because I did this, I put it in the wrong place. 35%. 7. There you go. 7 is 35%. But if you put the whole number in the wrong place, or if you put the number in the wrong place, in this case, if you put the 7 as a denominator instead of a numerator, here's what's going to happen. You're saying, instead of 7 being 35%, now you're saying 7 is 100%. But again, that's not what the problem says. It's 7 is not 100%. It says 7 is 35%. So it does matter where you put the numbers, okay? So 7 is 35, okay? Now, I can scale up. Guys, and I'm warning you, you have to know your times tables. 7 times 5 is 35, great. What number times 5 gives you 100? Now, if you can't think of it, you're going to have to do some division. Okay, I realize I went kind of fast. 5 times 2 is 10. Anyways, so the answer is 20. And I put it in two places so you can see what's going on. 7 is 35% of 20. Okay, so if 20 was the whole thing, 20 books, 100% would be all the books. If you only had 7 books, that means you only have 35% of all the books that you're supposed to have. And that's it, guys.